Hey everybody, welcome back to chemistry. Let's go ahead and try achieve 5, question 6, so I can blow up the slide. Okay, so the question reads as follows. Determine the number of unpaired electrons in the vanadium 2+ ion. So the first thing I want to point out is where vanadium is in the periodic table. It is atomic number 23, so it's here. So if I can reduce the slide. So we know that vanadium has 23 electrons, but we really want to find out how many unpaired electrons there are in the vanadium 2+ cation. And so that is vanadium 2+, and it's 21 electrons. Okay, so I think the best way to figure that out is to first write out a orbital notation for the vanadium atom, and then we'll figure out an orbital notation for the vanadium 2+ cation, and then through the orbital notation we can sort of see how many unpaired electrons there are. So one of the things you have to do is you have to figure out the order of sublevels that are filled by the 23 electrons of the vanadium atom. And then we'll go ahead and do the vanadium 2+ cation. So how do you figure out the order of sublevels? And well, you need to know the diagonal rule, so I will just remind you of that. This is a way of figuring out the order in which the electrons fill the orbitals in an atom. So you put 1s like that, and then you have 2s underneath, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, okay? And so then we draw diagonal lines like this. So the first diagonal line goes through 1s, the second diagonal line goes through 2s, third diagonal line through 2p and then 3s, and then 3p, 4s is the next one. Okay, so it looks like the order of the orbitals is this. You look at the first diagonal and it goes through 1s, so that's the first one that is filled. And then we now have to go to the second diagonal and it goes through 2s, and so that's the next one that is filled. And then we go to the third diagonal, and that goes through 2p first and then 3s, so it's 2p and 3s. And then you have to go to the fourth diagonal, 3p, 4s. And then I guess you were going to need a fifth diagonal here, because as I recall, we're out into the 3D with the electron filling. So now the next one is 3d, and then if you were to go out further, it would be 4p that would be next. Okay, so what I'm going to do now is I'm going to go ahead and write out an orbital notation first of the vanadium atom, and then I'm going to use that to figure out the orbital notation of the vanadium 2+ cation. So here we go. So we have 1s, and there are 2 electrons there. So we need 23 electrons, right? We're now down to 21. So next is 2s, and then we have 3 orbitals in the 2p. There are electrons going like this, 1 in each orbital before we put a pair in the orbitals. And so now we're up to 10 electrons, 13 to go. And so the next is 3s. And so the next is, looks like 3p. And then the next one is 4s. And I think at this point we have 20 electrons. Let me count. We have 10 here, and then we have another 10. Yes, we're at 20 electrons. So we have 3 more. So after the 4s sublevel is filled, you go into the 3d sublevel. As you know, there are 5 orbitals in the 3d sublevel, so let me write them out. 1, 2, 3, 4, 5. So here is the 3d. And so the last 3 electrons go like this. 1 in this orbital, 1 in this orbital, and 1 in that orbital. Okay, so this is the correct orbital notation for the vanadium atom. But really what we want is we need a orbital notation of the vanadium cation, and then we can figure out how many unpaired electrons there are. So I'm going to write out the same thing to a point, and I'll explain to you how the vanadium cation is different. So let me just quickly do this. Okay, so what I've done is I've written out again the vanadium orbital notation. But what I want to do is remove electrons from it to show you what the vanadium 2+ cation looks like. And so you have to remove 2 electrons from this orbital notation for the vanadium 2+ cation so that we're down to 21 electrons. So you have to figure out which 2 electrons to remove. And so one might think at first that you might remove the electrons that were last put in. So if you use that rule, then these 2 electrons would go. But one thing you have to remember with electron configurations for cations, that if you have any electrons in a d sublevel, you have to recall that you have to remove them from the numerically higher s sublevel first before you remove them from the d. So here, with this vanadium configuration, we have electrons in d, but because of that rule, we have to remove them from the 4s sublevel first. So if we want the vanadium cation, we remove those. So this is the correct configuration for the vanadium cation. And you can see here that there are no electrons in the 4s. Draw a better line there. No electrons in the 4s. We still retain 3 electrons in the 3d. And so the question asks you, how many unpaired electrons are there in the vanadium cation? And what you can see is the answer is there are 3 unpaired electrons. Okay, thank you for listening. We'll see you next time.